Verification of law of conservation of energy principle in the case of freely falling body. So first, what is the law of conservation of energy? So conservation means some meaning of conservation is nothing but no change or remains the same or constant. So statement of law of conservation of energy principle: energy can neither be created nor destroyed. If it disappears in one form, it reappears in another form. So the energy can be changed from one form to another, but the total amount of energy of the system is always constant. So this is called law of conservation of energy. So we are going to show this in the case of freely falling body. In various cases, the total energy of the freely falling body remains constant. For this, we are taking a freely falling body, students. So verification: let a body of mass m is at height h from the ground. So it is the figure. This arrow mark shows that the body is a freely falling body. The body is at the point A, which is at a height h from the ground. So mass of the body is m. So now it is a falling down freely under the influence of gravity. So as it falls under the influence of gravity, its potential difference its potential energy decreases and kinetic energy increases. So potential energy changes into kinetic energy. So you know, for every freely falling body, initial velocity u is a 0. As the body is a freely falling, so it has an acceleration due to gravity. So that is a is small z. So a is taken as small z, where g is acceleration due to gravity. So at the point A, when the body is present at the top, that is at the point A, so what are its potential energy and kinetic energy? So at the point A, due to height, its potential energy is mgh. So you know, potential energy gained by the body because of height. So due to height, its potential energy is h. Now initial velocity u is 0. Now what is its kinetic energy? So we know the formula: kinetic energy Ke is half m v square. But here v is taken as initial velocity, students, that is u. So this is half m 0 square, that is 0. So now total energy of the freely falling body E is equals to Pe plus Ke, that is mgh plus 0, which is equal to mgh. So this is the total energy of the freely falling body when it is at the point A, equation 1. So due to 0 velocity, its kinetic energy at the point A is 0. So now consider the freely falling body reaches the point B, means that it travels a distance vertically in the downward direction x. Then remaining height from ground to this point is h minus x, because total height is h. So from A to B, the distance traveled vertically in the downward direction is x. So height at which the body is present is h minus x. So now at the point B, what is the, so distance traveled s is x, height of the body from the ground is h minus x, then potential energy of this is mgh, but h is, this is, we want to take h minus x, mg of h minus x. So this implies potential energy Pe is equals to, multiplying with mg, students, mgh minus mgx. So this is the potential energy of the freely falling body at the point B during its journey in the downward direction. So what is the kinetic energy at the point B? So you know, initial velocity u is a 0. At the point B, final velocity is taken as a v1. And we know that from third equation of motion, v square minus u square is equals to 2as. This implies v square means v1 square, u square means 0 square, that is a 0, equal to 2 into a means g, students, acceleration due to gravity. Here s means x, that is from A to B distance traveled is x. So this implies V1 square is equals to 2gx. Now what is the kinetic energy? So now kinetic energy of the body at the point B is mv square, but here v is taken as a v1, that is half m v1 square, that is half m v1 square means we calculated just now into 2gx. 2 get cancelled, so kinetic energy Ke is equals to mgx. So this is now total energy of the body. So kinetic energy of the particle at the point of the freely falling body at the point B is calculated as mgx. Then total energy of the freely falling body at the point B is potential energy plus kinetic energy. But potential energy is calculated as Pe plus Ke mgh minus mgx plus Ke. Ke is mgx. mgx get cancelled, so this implies total energy E equal to again mgh. It is equation number 2. So now let the body is close to ground, that is at the sea, that is distance traveled here from here to here, that is close to ground means height is a 0. So now in the third case we are going to calculate the total energy of the freely falling body. So when the at the point C, so we take a height h as 0. So this implies potential energy Pe equal to mgh, that is mg into 0, that is 0. So now, so in this case also freely falling body initial velocity u is a 0 and final velocity v is taken as v2. From third equation of motion we have v square minus u square is equals to 2as. But here a means taken as acceleration due to gravity plus g. S is total height travelled, but in this case total distance travelled is h meters from top to bottom. So S is taken as h and v is taken as v2. So this implies from third equation of motion v means v2 square, u means 0, initial velocity 0, that is 2 into a means g and h. So this implies v2 square is equals to 2gh. v2 square is equals to 2gh. So now at the point C, what is the kinetic energy? Half mv square. V is taken as v2 square, that is why it is written as half m v2 square. So Ke is equals to half m into v2 square means that is 2gh. 2 get cancelled, that is mgh. So at the point C, for a freely falling body, kinetic energy also came as mgh. Now total energy, students, total energy E equal to potential energy plus kinetic energy. Potential energy here came as 0 and this is mgh. So total energy here also mgh. So this is equation number 3. So now you can see equation 1 total energy is mgh. Equation 2 total energy is mgh. Equation 3 total energy is mgh. So from these three equations, that is from equation 1, equation 2 and equation 3, total energy remains constant. So hence law of conservation of energy is verified in the case of freely falling body. So you can see again from top to bottom. So law of verification of law of conservation of energy principle in the case of freely falling body. First we want to write law of conservation of energy principle, then So verification using a freely falling body. So in the case of freely falling body, initial velocity u is always a 0. Acceleration due to gravity is a small z, that is positive. And here distance traveled in one case x, and this is the height when the body is at b, and this is a height. So this is the students, that's all.